Hello, this tutorial will show how to remove the insides of a model to get it ready for 3D printing. This model was made in TurboCAD, but the same procedure would be applied if the model was made in a polygon modeling program such as Modo. Now, the camera looks at the center point of the screen, and when you rotate the model rotates around that center point. To change the center point to another location, we just have to place the cursor over the model and click the middle mouse button, and now we can rotate in a different location. To return to the default center point, just click off the model. Now we'll click on the model again here. Now down here we have a button, and if we click this will lock the center point. So if I now click on the empty part of the screen, the model will no longer return to the default center point. So now I'm going to click down here near the nose, and we'll just move the model around and zoom in. Okay, now we'll go to the Tools Triangle Relocation module, and our whole model turns green. And now I have to rotate down here using this button, and we can see the model is all green. Now, if this model was ready for 3D printing, and I'm going to hold down the Shift button and just click on a green triangle with the right mouse button, if this whole model would have been ready for 3D printing, the whole model would have turned red. Right now, just the nose turned red, and this indicates triangles that are selected so we can move them over to a new layer. This model only has one layer. So I'll click down here, move to new layer, and I have to type in a name, so I'll call this Shell 1 and press the Enter key, and we've now moved all those triangles from this part of the model over into a new layer called Shell 1, and it's so now I'm going to turn off the top layer, and you can see that this model has triangles on the inside. So this was actually a closed watertight model. So now to select this model, this mesh for working on, I'll just hold the cursor here and click the right mouse button, and it's all selected. Now I'll rotate the model around, and now I could just click on each one at a time to select the triangle for moving, but instead I'll hold down the left mouse button and move around and circle all the polygons, let them go, and they all turn red. And if I go around, all the rest are green. Okay, so what I'll do is I'll move these over to a new layer called Trash. Later on we can just delete these because we won't need them anymore. Okay, so now it's on Trash, and if I turned off Trash, okay, you can see we've got a nice hole there. Okay, so now I'll go back and turn on the first layer, and okay, here's the rest of our model. I'll move over to here, and I'll click the right mouse button, and we'll zoom out, and you can see that okay, we got the whole model back to being green. So I'll just click in this area here with the middle mouse button, zoom in, and now on these triangles here, I'll just start here. I'll hold down the Shift key and click the left mouse button, and a whole bunch of triangles turn red. Now you can see they only travel to this point because this part of the model is not connected to this part, and if we rotate around, you can see that they're not connected there either. So I'll move this to a new layer, and we'll call this one Shell 2. I like to put stuff on lots of layers as I work on repairing the model, because all I have to do is merge all layers at the end, and they'll all be back into one model. So now I'll click on this layer with the right mouse button, and okay, it's green. We'll turn off the parts of the model we don't want to work on, and if we zoom in, we can see that there are triangles here, and we've got another surface in here. So if I just hold down the shift button and click, turn them all red, and again we will go around here and circle. Okay, those have turned green. Let's check. We've still got some more up here that aren't, so I'm just going to I could click on them one at a time, or I could go around and circle some of them. But if I get too wide open, you can see some of these others are changing, because they'll just keep changing around. So I probably didn't do that very good. And so we just get turn all the ones, whoops. Okay, that looks good. That's good. You can see some red ones here on the end, so we want them all to be red, because these we'll move off to the trash layer. And if we rotate this way, you can see the inside of the model is all red for moving out. And we come up here on the end, come in, they're all red. And so now I'll just go down here, click here. I want the trash layer, so we'll move to an existing layer, and there they are. So now if I turn off this layer and turn on trash, okay, you can see everything we've moved over to the trash layer. And then I can just go back again, turn on the other layers, and there's the whole model. So we'll turn off the trash, and we'll click over here. Okay, we've got all green, and so now I'll go hold down the shift key, click here. They're all red. Turn off shell 1, shell 2. Oh, we need this one on. And okay, so you can see there is a whole bunch of other structure inside that we won't be needing. So we'll move this over to a new layer, and we'll call this one shell 3. Okay, turn off that, turn on whoops. Okay, click here and hold down the shift key, click, and now we'll just bring this up and zoom in, circle around them again, turn those ones green, the other ones are red, nice and red on the end. Okay, click those, turn the okay, they're all red. So now we come back down here, select trash layer again, move them to the trash, and so we've got all that part of the model. And then if we turned on this part of the layer again, okay, we can see all this part of the model in here. Now we don't need this inside stuff, and so let's see what happens. I'll first select the layer, hold down the key, and it's select. Okay, let's turn off that shell. Okay, so now I'm just going to carry on. Clicking all these. And select as many as you want. Move them to trash. Carry on. Now you'd have to be careful because sometimes you don't know what's happening, and they could zoom in and take out ones you want, so then you would have to move them from the trash layer back out onto a useful layer. And so we've got rid of it, and so on. We'll just go to here, move to existing layer. Okay, they're all on the trash. I missed something there. Okay, move those to trash. Okay, then we can say we'll exit this module. Now I know at this point in time I don't need the stuff on trash, so I'll just turn on the trash, and I'll go down here and click on my delete layer button, and since only trash is selected for displaying, that layer is automatically selected, and I'll just say I want to delete it, and it's gone. If I wanted a prompt, I'd click this on and I would get a prompt before deleting. Close this module down. Okay, and there's our model. And so now you can carry along on the same method and clean out all the triangles that you don't want inside the outer shell. Now, as this model was built, when it came out of CAD, it would have had multiple layers. And if I was going to remove the inside triangles I didn't want, I would have removed those triangles then before putting the model all together onto one layer. Now, if we come over to into another work area, this is the model again, and you can see here there's 258 layers. What I did is I took the STL file into a development version of AccuTrans, and it's got a new feature where it identified all the different meshes that made up the model and moved each individual one off onto its own layer for working on. And so we can see what happens. I'm going to hold down both the control and the shift key and click with the right mouse button to turn off a layer. And there you can see there's one layer turned off. There's another one. We're leaving something in here. Go with the click, click, click. Okay, there's our inside one, so that you could then take and work and do what you want. So let's carry on. We'll go to here. This is one that I was working on that was off the one we just wanted, and I created all the shells. So I'll turn off all the layers and then just select the shell. Now the model isn't ready for 3D printing because it wasn't built that well in TurboCAD. What you have to do is you have to learn what's needed for meshes and then revise your building technique, whether it's in a CAD program or a Polygon program, for learning how to build a mesh so it comes out right to give you the least amount of work to repair the model. So I'm just going to click in here where we had two meshes come together. Now, if we zoom in real close, we can come in and turn it, and we can see that we've got a hole through here. I'm just going to turn on the Edit Vertices mode and select the nose cone, and so we can see the edges of the triangles, and this is the selected layer, and we can also see where the vertices are, and these vertices are in gray too. Now what happens is you can see that after the vertices are not lining up good, and we have a really ragged looking edges. Now we could slowly fix this in AccuTrans, but it would take a long time to do it, and just depends what you want it to match together. I could click on Pick Edge here, pick this vertex, pick this one, the edge is selected, the red line, click Divide Edge, and now that edge is divided. And then I could click on Pick Vert mode, select this vertex, do Snap to Vert, click on this vertex, and now we're closing in, and then say OK. Then I could go back to Pick Edge mode, click that. The lines turn red, showing which edges are connected to a selected vertex. Click here, and then divide that edge. Go back to pick vertex mode, click on the vertex, snap the vertex, click there, click OK. Now this would take ages to fix up the model, but if we had modeled right in the CAD program, we wouldn't have all this to do. Now, what happens in a CAD program? You're using mostly parametric drawing entities, where an equation represents what's going to happen. So if you're going to draw a circle, you just have an equation for a circle. And if you're going to do a cylinder, you have another equation which is going to make you a nice perfectly round cylinder. Now, when you have to convert that parametric model over to a polygon model, you have to approximate any curves with line segments, and then you get triangles when you do a curved surface. So what happens to get these to line up? You always have a starting point for a circle or an arc or whatever, and so what you have to do is you have to use the same starting point for this object and the same starting point for this object, plus you have to specify the same number of segments that the arc or circle will be divided into, and you have to use the same number and the same number on both of them, so that every vertex lines up and they match together perfectly. And then also, now if we come over to here, we'll go back into edit points mode, and I'm going to select this half of a cylinder here. Now, what we also have here is another problem, is when these two halves were made, besides picking corresponding starting points, if you're doing an arc of any size less than 360 degrees, you have to have both the same starting point and the both ending point. And what happened here is we have an overlap of the two meshes because we have different starting and ending points on the two meshes. So you have to make sure those are right, and if they were, then these would have matched up, and there wouldn't have been any hole. And this continues throughout the model as you go along, and we don't have things matching up. Then here's a case where they do match up, and if we continue along, they match up there, but when we get over to here, we can see they don't match up. So with care, you can eliminate that. Now, what are some of the problems you get into that you have to work on when you're making the model? We'll go to this work area. Now, if I do a watertight check here, it says meshes are watertight. Okay, but what now? This is sort of AccuTrans only checks the meshes on a per layer basis. I have them on 2 layers so that you can see what the difference is. So I'll turn off this mesh, and if we go around, we can see that, yeah, it's got no holes in it. If we turn this mesh off, turn this mesh on, we can see, okay, there are no holes. So now what I'll do is I'll turn both meshes on, and now I'm going to do a merge all, and we'll merge all layers into one mesh. I'll say yes, and then I'll do a watertight check, and it says the meshes are watertight. Now, AccuTrans doesn't do all the checks that are needed beyond a simple watertight check. Now what we have here is coincident triangles. We have triangles from this surface and from the surface we can't see. They are laying in the same plane in 3D space. And what happens is that will cause the software running the 3D printer to have problems. So what we have to do is we have to actually make it so these two join together with no overlapping triangles. So if I go here, okay, this looks like the same model, but what I'll do is I'll turn off the there, gotta move it so we can, let's put on display flat shading with edges. Okay, now if I move, okay, now we can see that there's a hole here, and now if I turn that one on, and this one off, come around. Okay, I can see there's a hole here. Okay, if I turn them back on, and now if I did the watertight check, AccuTrans is going to find a hole on both layers, but since it's a corresponding hole, we only see one hole. So let's get rid of the watertight check layer, come back, merge all layers together, yes, do a watertight check, yes. Okay, so that's how you get around that problem. Now, another problem is we do a watertight check, and it says meshes are watertight because they're both closed. But if I turn off the sphere, there's the triangle. It's got no holes, and if we turn off the rod and look, there's no hole in the sphere. Okay, so we'll merge them all onto the same layer, do the check, and do a watertight check. They're tight, watertight, but that may or may not print. That's actually an improper way to make a watertight mesh of one object. But what's happening is companies are revising their software so that they will actually print this, where before at one time all printers wouldn't print this, but now some of them will. So it's a guess when you go to a service provider whether they will or will not print that model. To make it so that anybody can print that model, we'll go to here, and what we do in this case is, if I did the watertight check, yeah, it says we've got holes, and if I turn this off, we can see, okay, we've got a common hole. If I put these on, get rid of that layer and do a merge all, yes, okay, and then do watertight check, it's gone, and that's because I cut a hole in the sphere and we moved the ends on there. We'll just reload that back in, and okay, turn that off. There's our hole that I didn't show you, and if I turn that one off and this one on, and there's the hole in the other end. So this model, once merged together, will print in all 3D printers. Now, another problem is, now we just looked at an intersection, and that was a partial intersection, and that one will work on some printers. Now, for those printers that will print that, they probably won't print this one because it's a full intersection with one mesh going completely through the other mesh. And if I turn the one off, we can see that, okay, this is all solid, and if I turn this one off and this one on, okay, this one is all solid. And if I merge them all together, do a watertight check, yeah, okay, they're watertight, but this will probably not print. Again, the way to fix it is to cut holes in the two meshes. So if we come here, if I turn off the one, okay, there's the holes in that one, turn that one off, turn this one on, there's the holes, turn them both on, do a watertight check, turn off the layers, okay, and there's our showing where our holes are. Clean that off, do merge all, yes, watertight check, okay, that will print on all printers. Then we come down here. Now this is another one doing partial. Now this one is a full intersect here, and this is a full intersect here, but we're only doing part of each object. And we could get more complicated. We could have one that's just partially coming in and meeting here and so forth. And if you get too many meshing together, again, they might not get printed, even on one that will print some cases of intersecting meshes. And so if we looked at these one at a time, okay, there, that mesh is solid, this mesh is solid, and this mesh is solid. And if we turn them all on and do a watertight check, it's watertight. If we merge them all, do a watertight check, yep, they're okay. Now again, as we did before, the way to make it work on all printers is to cut holes. So now if we turn these off, okay, now what I did here is I cut a hole on both sides so that it's completely open on the inside, cut that corner out, and so it's nice and hollow in there. Okay, turn this one off, turn this one on. Okay, for that one that went all the way through, cut the center section out, and then for the one that was up in the upper corner, we cut a chunk out of it like that. And if we put them all together, do a watertight check, there's holes, look at what they are. Okay, there's showing where our holes are. Clean that out, do merge all, and merge them all together, do a watertight check. Okay, that will print on all the printers. Now, going back to our model of the missile. Okay, so now if we want to did I clean everything? Oh yeah, I forgot I turned all the layers off. Let's turn them all on. Okay, now we have other meshes here which we need to model different so that they get cut into the model. So what I'm going to do is turn off that layer, turn off that layer, turn off this, turn off these ones. Okay, so now if we look at this part, we can see, okay, we have a mesh coming through, and it's coming through onto the inside. Now these look like they're coincident triangles, or just about coincident. And so what should happen here is we should remove the bottom triangles on the piece should be removed, and then we should cut a hole in these two triangles so that this will mesh right nicely together, like I showed in the other work areas. Now, coming along, we'll turn everything back on again. Now, okay, we'll turn off some layers and turn this off. Okay, so now we come down here. We have some thrusters. Now, actually, the thruster is made up of two meshes, one here, one here, and there are some problems there. What we have is, again, this mesh passes all the way through this mesh. If I just go down to Tools, Triangle Relocation, select this one, and I'm going to just select some of the triangles, and this I'm going to hide them. I'm not actually deleting them, but anyway, we'll just turn. And so now you can see that this mesh is going through this. So this actually has to be all cut up and fitted nicely so that it's forming a proper watertight mesh if you want it printed on all printers. But what you could do is you could run a test where you could just take this one part and send it into your 3D company of choice and see if they can print it with intersecting meshes, and if they can, then you don't have to worry about it. And so now I'm just going to click OK, and there all our meshes all our triangles come back because we were just hiding them. Now go back into the edit mode, click there. Now I'm going to click down here, and let's see, I'm going to turn off this layer. Okay, now click down here now. Okay, I'm going to zoom in on the end here. Now, when this has a hole in here because what we had is we made the biggest part of the mesh. We used one set to turn an arc into segments. We used one count of segments, but when we went to this, on this arc, a different count of segments was used. So you can see there are holes because they didn't match up. The way to fix that, if you'd only have a couple of these, again, is to take and go into pick edge mode, click on one vertex, click on another one, do divide edge, click vert, pick vert, click on it, do snap to vert, click on that, do OK. Okay, that's fixed. And then we would just carry along doing the same. Divide the edge, pick vert, pick it, snap to vert, put it in, and OK. And then you could work your way through all of them, and you could get rid of those holes. Now we get down. Okay, we'll go back. We'll turn on the whole model again, and we'll click, and we'll come around. This really needs a lot of work down here once we get down to all the nozzles, because there's segments of all kinds of meshes. We have all kinds of watertight meshes which are all touching and intersecting each other, and then some of them are open. And then we have here, now if we have our support rods coming in, and if I was to turn off this box in the middle, we can see that, okay, they're closed meshes coming together and penetrating one another. Now, this one penetrating the square box that I turned off is probably okay. These two intersecting together and then intersecting the box could cause the 3D printer software problems, even though they are selecting intersecting meshes. And the box that I turned off is actually a closed mesh. And if we come down, like if we come into here and click, I can turn off this mesh, and you can see again that was a closed mesh penetrating into this watertight mesh. And if we go over to here, okay, here's our nozzle, and then if we did a watertight check, and this has got holes, so we'll turn everything off but our holes. Okay, and here's where it says we've got holes, and actually that's a shear, that's okay, that one's okay, that's okay, and it's one of these. Okay, there we go. And then here, okay, so now if I turn off all the others, okay, these are actually they're rings that are open on the bottom, and that's why they registered as holes. Now that could be closed off there, and if it does intersecting meshes, then that could possibly print. But the best way to do it all is to actually Boolean all these together so that we've got proper holes and everything else, and make a proper mesh as I was showing with intersecting polygons earlier. So that's it for removing meshes and showing things you have to watch out for in the model. And since you're working in CAD, before carrying on getting big models ready for 3D printing, I would suggest that you work on using the tools in the CAD program to figure out how to make the meshes better, so that you get everything lining up, so you have very little work to do in AccuTrans or another program to make the meshes watertight. Goodbye.